Today we are solving Leetcode 2751, robot collisions. Before we get into the actual problem, let's start with a short analogy. If you'd prefer to skip it, you can move to the next timestamp where we begin the problem directly. Imagine scouts inside the walls from Attack on Titan. Some scouts are moving to the right and some are moving to the left. Whenever two scouts moving in opposite directions meet, open quote, they fight, close quote. The rules are simple. If one scout has less health, that scout dies. If one scout has more health, it survives but loses 1 health. If both have equal health, then both die. Now here's the important observation Commander Irwin makes. Scouts moving to the right are basically waiting for enemies ahead. And when a left-moving scout arrives, it will always fight the closest right-moving scout first. So instead of checking every possible pair, we just track all right-moving scouts in a stack. And when a left-moving scout arrives, it fights the top of the stack and keeps fighting until the situation is resolved. That is exactly the strategy used in this algorithm. Now moving to the actual problem. We are given 3 arrays: positions, healths, and directions. Each robot moves either to the right or to the left. All robots move simultaneously on a number line. Whenever a right-moving robot and a left-moving robot move toward each other, they will eventually collide. The collision rules are: if one robot has smaller health, it dies. If one has larger health, it survives but loses 1 health. If both have equal health, both are destroyed. Our goal is to return the healths of the remaining robots in their original index order. Now, if you try a brute force approach, you would compare every pair of robots. That would take big O of n squared time, which is too slow. Now let's talk about the key insight. Only a robot moving to the right on the left side can collide with a robot moving to the left on the right side. So collisions only happen between right-moving robots on the left and left-moving robots on the right. Because of this, we first sort all robots by their positions. This takes big O of n log n time. Sorting ensures we process robots from left to right exactly how collisions happen physically. Now we use a stack. This stack stores indices of right-moving robots. When we process each robot, if it is moving to the right, we push it into the stack. If it is moving to the left, then it will fight with the robots in the stack. Now let's understand the collision loop. While the stack is not empty, we look at the top robot in the stack. If the top robot has less health than the current robot, then the top robot dies. We remove it from the stack, and the current robot loses 1 health. If the top robot has greater health, then the current robot dies. The top robot loses 1 health, and we stop. If both have equal health, then both die. We remove the top robot and stop. This process continues until either the stack becomes empty or the current robot is destroyed. Now, why does a stack work here? Because of last in, first out behavior. The most recently added right-moving robot is always the closest one to collide with an incoming left-moving robot. So the stack naturally gives us the correct collision order. Now let's walk through an example. Positions equals 3, 5, 2, 6 healths equals 10, 10, 15, 12 directions equals RL, RL. First, we sort by position. The order becomes robot at position 2, robot at position 3, robot at position 5, robot at position 6. Now we process one by one. First robot moving right with health 15, we push it into the stack. Stack becomes 15. Second robot moving right with health 10, push again. Stack becomes 15, 10. Third robot moving left with health 10. Now collision starts. Top of stack is 10. 10 versus 10 equal both die. We remove the top robot. Stack becomes 15. Next robot moving left with health 12. Now it fights with 15. 15 is greater than 12. Right robot survives. Its health becomes 14. Left robot dies. So the final survivor is health equals 14. Answer becomes 14. Now let's understand why this approach is efficient. Each robot is pushed into the stack at most 1 time. Each robot is removed from the stack at most 1 time. So total stack operations take big O of n time. Sorting takes big O of n log n time. So overall time complexity is big O of n log n, and space complexity is big O of n. Now let's summarize the pattern. When you see objects moving in opposite directions, nearest collision matters. Chain collisions happen one after another. This strongly indicates a stack simulation problem. The core idea is Sort robots by position. Push right-moving robots into a stack. When a left-moving robot comes, simulate collisions using the stack. Return survivors in original order. And that's the complete idea behind this problem. Thanks for watching. If this helped, consider liking, commenting, subscribing, and sharing. For more problems explained like this, check out the playlist linked in the description. Tarakai.